Okay, good morning, everyone. Okay, welcome to our September crash course revision session. Okay, today we'll be covering the topics on mole concept and chemical bonding. Okay, I think that most of us are here as a Sec 4 student. I think most of us are either taking pure or combined Sec 4. Okay, there's a small minority of Sec 3 students here as well today in today's session. Okay, now in today's lesson, we'll be covering the two topics, okay, mole concept and chemical bonding. I think most of us are okay with chemical bonding. Okay, there are just some things that maybe I would like to highlight again for these two chapters. For mole concept, I think some of you may find it slightly more difficult, okay, especially at this point of time. Some of us, our foundation for mole concept is still not very strong. Okay, now to today's session, I hope that I can bring you some value, okay, in terms of whether or not you learn something from today's lesson, as well as some of the tips that I can potentially share with you on how to solve questions involving mole concepts. Different formulas, how do you use the formulas, when do you use which formulas, so that you can actually do well for these two chapters. Okay. Now, first off, in the chapter of mole concept, we must understand, okay, the whole idea of mole concept is to help us to find a common ground to calculate certain calculations for chemical equations. So for example, let's say I have a very typical reaction. Let's say I have NaOH that is going to react with HCl, okay? For those of us who didn't manage to print out the notes or didn't manage to have an annotatable copy, can you just take out a piece of paper, and a piece of paper would suffice as well, lah. Then you just write down with me along with the lesson for the notes. All right. Okay, now speaking of which, I have this reaction NaOH plus HCl. It will give us sodium chloride, very standard, as well as water. Now, for me to understand these two compounds that are going to react together to form me the salt, okay, to form me the salt, I need to understand what is the ratio in which the NaOH is going to react with the HCl to form the salt. Now, this is where mole concept comes in, because NaOH and HCl are fundamentally two different chemical compounds. I cannot just anyhow add them together. If not, I will have excess of this, I will have excess of this. Okay, I'm not sure which one I have in excess. So that is the reason why mole concept is important, is help us to calculate what is the ratio of this compound going to react with the next compound. Okay, now that's just a recap for you. Now we go on to talking about the formulas involved in mole concept. Okay, can everybody write down the word mole in the center of the page? Okay. Now, I'm trying to make every formula come in together on this page itself, so that when you are doing your revision, then you are able to just look at this piece of paper and then you can remember all of the formula for mole concept. Okay, first relationship is between mole and mass. Now, can anybody tell me, from mole to mass or mass to mole, what do I do? How do I convert between the mass to the mole? Good. So when I'm converting from moles to mass, okay, I'm going to use the ratio multiplied by this term known as molar mass. Okay. Now, similarly, if I'm going to convert from mass to mole, this one I will divide by molar mass. Now, this is the first relationship you need to know. How do we convert from mole to mass? The most important one. Okay, what is molar mass? Molar mass basically, okay, it is the MR of a compound, okay, in grams per mole. Okay, so molar mass, the units you need to be aware as well. Okay, how do we convert from mass to mole? How do we convert from mole to mass? Can Okay, so this is the first relationship you need to know. Now, second relationship you need to know is known as what we call the Avogadro's constant. Okay, now from mole represent a number, okay, of atom. Okay, it represent a quantity of a compound. So when I convert from mole to number of particles, okay, number of particles, particles meaning to say it can be either a neutron, it can be a proton, it can be an electron, it can also be an atom, a molecule, or an ion. These are all particles, okay? Now, for example, if let's say I have 1 mole of hydrogen atoms, okay, atoms are, if I want to convert to the number of particles, I will multiply by this thing known as the Avogadro's constant times 6 times 10 to the power of 23. This is an important number as well. Most of the time, it will come up in terms of an MCQ question for Avogadro's constant. Most of the time, okay, it will come out in terms of an MCQ question. So when they tell you that there's 0.5 mole of, for example, NaCl, they want you to calculate how many number of particles there are actually in the sodium chloride. This is the formula that you use. If let's say I want to find a concentration, okay, in terms of mole per dmq, how do I do that? From mole to concentration. Concentration is what? Concentration is number of particles per unit volume, right? So in this case, we are talking about number of mole per unit volume. So I will divide by volume. Okay, this is in dmq. Okay, so to get for concentration to mole, I multiply by the volume in dmq. Can ah? Okay, can ah? Okay, next. After you have gotten this, now, if I want to find the concentration in terms of grams per dm cube, how do I do that? If I want to find concentration, okay, in terms of grams per dm cube, sometimes question may not want you to give mole per dm cube. Sometimes they ask you to find grams per dm cube. Yeah. Okay, so grams per dm cube, how do I do? Mole to gram, how to convert? Mole to gram, I multiply by molar mass, right? So similarly, I should also multiply by the molar mass. Okay. Then to convert backwards, also divide by molar mass. For moles, we are going to convert to this thing known as gases. Now, if I want to convert the mole into a gas, I can find the volume of a gas. And this volume will come in dm cube. How do we convert mole to volume? This one, do you remember? Anybody remember of gas? Yes, very good. Thank you, Emma. Thank you, Rachel. Thank you, Cheryl. 24. Okay, good. So I will multiply by this thing known as the molar gas volume formula. Okay. And importantly, you need to know that this formula, or rather this molar gas volume, has a number of 24. And the important thing about this is that this 24 dm cube applies for all gases. Okay, this applies for all gases, okay, at room temperature. Okay, at room temperature. Most of the time, or if not all of the time, O-level will give you in room temperature. They will not give you in other temperature. Okay, they will always ask you to use molar gas volume. Okay, can So this is a short summary of all of the relationship between the moles as well as the MR. Let's identify the ones that are talking about gases. Gases is these two formula, right? The one that is talking about, the solutions, okay, aqueous solutions is this one. Volume in dm cube. Conversion of moles to concentration. Okay, concentration in aqueous solution. Okay. Then talking about particles is this one, 10 to the power of 23. Okay. And of course, mole to mass, this one is very important. You need to always be aware of this. Okay. Now, with that understanding, shall we try out some question for mole concept? Later, you can identify which are the formula that you need to use for a certain concept. Now, there are other concepts, or rather there are further concepts, for example, percentage yield and percentage purity for mole concept, but you need to understand that they are just an extension of this, okay? Later, when we come to the questions, we will discuss on it. All right? Okay, let's look at question number 1. Now, we go through very quickly for MCQ question, then I spend some time on the structure questions. Now, let's look at question number 1. Now, under the question, they tell us that calcium reacts with water as shown in the equation. Now, typically in chemistry O-level question for mole concept, either one of these case. One is it will be a super long question in paper 2. If not, it will be a short question in paper 1. So you need to know how to use the formula or how to strategize to make sure that you are able to do this question in the time that is allocated for you. Now, in paper 1, it's very common for them to give you an equation and ask you to do some calculation. Now, let's look at this together. I have calcium going to react with water to form calcium hydroxide and hydrogen gas. Now, they tell me that I want to find out what is the total mass of solution after 40 grams of calcium reacts with 100 grams of water. Now, one of the important things you need to understand is the concept of mole ratio. Mole ratio means what? Can you see over here that one of the calcium is going to react with two of the water molecule to form one calcium hydroxide and one hydrogen gas. This is what is meant by mole ratio. So with that understanding, can you see that if let's say that I have 2 calcium, I need 4 moles of water to produce 2. Okay, so it's a multipliable equation. I can in a number of times or multiples of this equation. Now, with that understanding, let's first understand how do we solve a question. Now, in mole concept, you will always follow these 3 golden rule. Number 1, find the number of moles, okay, of given substance. Now, what do you mean by number of moles of given substance? Basically, when the question gives you a value, a known value of a substance in the equation, that is what is meant by I will first find the number of moles of this given substance. Okay, let's do that. Now, so the first step will be very simple. I'm going to find the number of moles of calcium equals to this formula. What formula will I use? Can anybody tell me what formula will I use for this? Okay, good. Thank you, Emma. Mass over MR. Okay, good. So mass over molar mass, mass is 40 grams. Okay, over molar mass. Now, molar mass of calcium, how to find? MR, go to periodic table. Okay, calcium is going to be 40. Okay, then hence you will realize that there's 1 mole. Okay, 1 mole of calcium. Now, with that, I can find out what is the number of moles of water as well. You will realize that your answer is 5.55 recurring lah. Oh. Okay, so with that understanding, can anybody tell me, is it calcium or is water the one that is limiting reactant? It will be used up fully. Okay, Melissa say calcium, Jasper say calcium. Anybody say it's water? Everybody think it's calcium. Okay, so limiting reactant works in this way. The one that will be used up at the end of the reaction. So can you see it's 1:2, right? It's 1:2. So that means that if let's say I got 5.55 water, that means I need what 2.75 calcium, right? But I only have what? I only have 1, right? So that means that this is in excess. Water is in excess. Excess reactant is an excess reactant. Okay, so with that understanding, let's try this. So there's 1 mole of calcium. It will produce us what? That will produce us 1 mole of CaOH2. Now, the question is this. I can find out what is the mass of CaOH2 that is being formed. It will be 1 mole, right? Okay, be 1 mole. So that means that based on number 2, the second step will be use mole ratio to find unknown. Okay, so I'm giving you a framework to find out how to do mole concept questions. Okay. And then in this case, the unknown is CaOH2, number of moles of CaOH2, okay, will be equals to what? 1, because here is 1, mole ratio is 1:1. Can you see that? So 1 multiplied by what? Multiplied by Ca, which is 40, okay, plus 18. 14 plus together, it should be 58 grams. Okay, sorry, 58, not 58 grams. Okay, 58. This is sorry, this is what? I'm finding number of moles, sorry, not finding number of mass. Okay, find number of moles is 1 mole. Okay, sorry, then I find what is the mass. Oops, mass of CaOH2 Okay, because remember, we are always finding total mass of solution, right? This question, it should be 58, okay, as mentioned just now. Okay, now with that understanding, okay, what is the total mass of solution that remains when 40 grams of calcium reacts with 100 grams of water? Sorry, calculation error. Shouldn't be 58 gram, it should be what? Ca calcium is 40 plus 17 multiplied by 2. Okay, so it should be 74. Oops, so it should be 74 gram of CaOH2. Okay, with that, can you please add the two values together? 63.999 plus 74. Okay, these two values, when you add them together, they should give you a value of 137.9. Okay, which most probably you will approximate the answer to 138. Answer is C for this question. Okay, so please make sure that you know, okay, what are the steps involved. Okay, yes. Mukundan say, can you just take 140 minus mass of H2? Yes, you can, because you know that H2 is the only one that is evolved, that escaped. So mass of hydrogen, definitely you can do that. It's basically the number of mole of hydrogen, which is 1 mole. Okay, multiply by mR times 2, give you 2 grams. Okay, so you can just take 140 minus 2 grams. Okay, it will give you this answer over here. Okay, can Okay, with that, let's go on to question number 2. Now, question number 2, hydrogen reacts with oxygen in the equation shown below. How much gas will remain when 2 dmq of hydrogen is reacted with 1 dmq of oxygen at room temperature? Okay, molar gas volume is where 1 mole of any gas occupies 24 dm cube of volume at room temperature. That means that, can you see, if let's say that you have 2 dm cube of hydrogen, 1 dm cube of oxygen, it will give me water, fully react, because they will give me product and no other gas. That means that 0 dm cube of gas will remain. Okay, they will be fully reacted. The mole ratio is exactly the same. Okay, mole ratio and volume ratio is exactly the same. Can Okay, next questions. Now, question number 3, sodium hydrogen carbonate decompose on heating. 5 mole sample of sodium carbonate is heated. Which volume of carbon dioxide measured at room temperature is evolved? Yeah, if you don't know how to do, give you a clue. Compare mole ratio between sodium hydrogen carbonate, okay, as well as carbon dioxide. Okay, is 2:1. So if let's say I have 5 over here, this should be 2.5. Okay, say D. Melissa say D. Okay, Richard say D. Okay, very good, fantastic. Okay, I think most of us managed to get D as the answer, right? So how do I do? Since I know that there's 2.5 moles of carbon dioxide is a gas at room temperature. What happens? I'm going to apply molar gas volume. So volume of CO2 is none other than, if I take 2.5 multiplied by 24, it gives me 60. Answer is D for donkey. Can question 3 okay Okay, we move on to question number 4. Now, question number 4 is a question that tells you to derive an empirical formula. Now, empirical formula is a formula that shows you what is the simplest number, okay, simplest ratio, okay, between atoms present in the element, in the compound. Okay, so this is the empirical formula. Now, if let's say in this case, I have percentage by mass nitrogen 47%, percentage by mass of oxygen 53%. Now, whenever we are doing empirical formula question, you will always come up with a table. I have nitrogen, I have oxygen. Now, first statement you will write is assume 100-gram sample. Okay, that means the mass is going to be 47 grams, 53 grams. Then I find out what is the number of moles. Moles will be 47 divided by 14 for nitrogen. It will give 3.357. What about oxygen? I take oxygen 53 divided by MR of oxygen, sorry, AR of oxygen, give you 3.3125. then you will realize that the mole is quite similar. Then you find what is the simplest mole ratio. Okay, how do we do? We take the mole divided by the smallest number. So in this case, I divide by 3.31, divide by 3.31. Hence, the answer I get is almost 1:1, approximately 1:1. So answer for this question will give you answer A. Can does anybody need me to explain this question in depth? If not, can you give me a thumbs up so I know that you are ready to proceed to next question? Okay, thank you, Rachel. Thank you, Izati. Okay, thank you, Melissa. Okay, good. All right. Now, let's look at the last MCQ question before we go on to structure. Okay, last MCQ question. Now, question number 5, you're told that copper 2 sulfate crystals, they are heated to produce anhydrous copper 2 sulfate as well as water vapor. They ask you to find out what is the mass of anhydrous copper 2 sulfate being formed. Can we try to do that? Can you try to do this question and then give me an answer inside the chat? Okay, Mukunda also say B, Grace also say B. Okay, very good. Okay, so first step is always to find number of moles, okay, of the substance, given substance. This one is none other than if you take 25 divide by the MR of the hydrated copper 2 sulfate, you will get 0.1 as your answer. Now, then after that, I take 0.1 multiply by copper 2 sulfate, right? So you will get 16.0 as your answer. Can Okay. So based on mole ratio is a 1:1 ratio. Okay, you get 16.0. Okay, so mass of CuSO4, okay, will be 0.1 multiplied by what? 64 plus sulfur is 32 plus 5 multiplied by 16. You will get 16.0 as your answer. Okay. All right, very good. Okay, so with that, let's go on to the next question. Okay, on molar gas volume. Now, this question, okay, is a question from a school prelim paper. Okay, I want you to take a look at this question, and then after that, let's try to do this together. Okay, in this question, you are told that the rate of reaction was investigated for a reaction between sodium thiosulfate and different acids. You are given that there are 3 different acids, hydrochloric acid, ethanoic acid, and sulfuric acid. Now, can everybody write down hydrochloric acid is what? Is it a strong acid, weak acid? Okay, and whether is it a monobasic or dibasic acid? Okay, so HCl is a strong acid. It is a monobasic. Good. Okay, thank you, Melissa. Now, ethanoic, can anybody tell me, is it a weak acid, strong acid, monobasic, dibasic, tribasic acid? Anybody knows? Okay, Grace say weak acid, very good. Is it monobasic, dibasic, or tribasic? By the way, what does basicity mean? Basicity means how many H plus, okay, forms when dissociated. Okay, yes, thank you, Izati, is monobasic. Can Okay, for sulfuric acid, right? Okay, it is a strong acid as well. Okay, but it is a dibasic acid, which means it produces 2H plus for every acid molecule that dissolves in water. Okay, with that understanding, let's go down. Okay, explain why. Okay, the question tells you that as the reaction progresses, they put a cross at the bottom of this setup. Okay, from the top view, there is a reason why they cannot see the cross anymore. It's because you look at the equation, there is a formation of sulfur. Okay, so you tell them that the formation of a sulfur, solid sulfur, as the reaction progress, okay, turns the solution, or maybe just say makes it unable for the cross to be seen. Okay, so this will be your answer for part A of the question. Basically, it is telling you that there's this equation, sodium thiosulfate reacting with HCl to form sulfur. I think this question, some of y'all have done it before. I think most of y'all have done it before. It is from a 10-year series, 2013 paper. Okay. Now, this is the part that I want you all to try. Part 2 show that by calculation that the volume of sulfur dioxide gas produced is 60 cm cube for experiment A. Yeah, so for those of us who don't know how to start, first off, because they tell us what is this, they tell us what is the volume, what is the concentration of HCl. I'm going to use the formula for concentration. Okay, concentration to find mole. So I find number of moles of HCl. Okay, volume times concentration. Now, when I have volume times concentration, what do I do? Find out what is the volume. Volume is 5 cm cube. 5 cm cube is in terms of cm cube. So I need to divide by 1000 to get into dm cube. Multiply by concentration. Concentration is what? Concentration is 1 mole per dm cube. Answer will be 0.005 mole. This is for HCl. Okay. Now the next step will be comparing mole ratio to find the unknown substance. HCl to what? Sulfur dioxide, right? Is 2 is to 1. Identify the two substances that you are comparing based on the chemical equation. 0.005, this will be divided by 2, 0.00250. Now they ask you to find out what is the volume of gas. So volume of gas will be equals to me having the number of moles multiplied by 24. This is a molar gas volume. Okay, you will get the answer. Okay, 0.00250 multiplied by 24. You should get an answer of 0.06. Now, this question is asking for what? This question is asking for cm cube. This value is in dm cube. So I need to do some conversion to get into 60 cm cube multiplied by 1000. Okay, volume conversion. So you'll get 60 cm cube. Your answer is shown. Okay, any question? No question? Okay. Oh, okay. Okay, now let's look at the next one. Next question is slightly more difficult. This question, if all okay, let's go to next question. Now, this question, okay, following equation represent the reaction between propanol and methanolic acid to form ester. Okay. They tell us that propanol is reacted with 4.0 gram of methanolic acid. Now, first off, can you all please try to find out which one is the limiting reactant? Okay, and then after that, you can do the part B and the part C. Okay, try this question. Okay, make sure you follow the presentation. Okay, number of moles of propanol, and then you follow number of moles of methanolic acid. Calculate the two values. I think you should get the same value as me. If you get a different value, can you please let me know? And then we write down the statement. Since the two compounds react in a 1:1 ratio, both based on mole ratio, okay, 0.1 moles of this propanol, you require 0.1 mole of methanolic acid to react fully. So we know that methanolic is limiting because methanolic acid is less than 0.1. Hannah, anybody have any question? If you manage to get the answer, can you give me a thumbs up so I know? Okay, Rachel managed to get the answer. Adawiya also managed to get the answer. Managed to get the answer. Grace also. Okay, good. Izati as well. Okay, good. Now, with that, let's go to second one. Name the ester form. Ester, this one is a bit of organic chemistry, although it's not very more concept. So for Sec 3 student, please bear with me. For Sec 4 student, this one you should know how to do. Okay. Name the ester form. Remember, whenever we are talking about ester formation, we always recall this thing known as ABC. Okay. Stand for alcohol before carboxylic acid. Please remember this, ABC. For ester formation, always remember the alcohol name will come first, followed by the acid name. So this ester should be propyl metanoate. Very good. Okay. Propyl metanoate. Okay, so when students in exam they don't know how to write the ester name. Do they put methyl propanoate or propyl metanoate? Follow this. Okay. A before C. Anyway, our alphabet is ABC. So A before C. Alcohol name come first. Carboxylic acid name come next. Okay, with that understanding, let's go to question part C, asking for maximum yield of ester form. Okay, so they are asking for maximum yield of ester form. Now, in other words, the question say maximum yield. Maximum yield means what? Maximum yield is when the reactants fully react. Okay, that means that the outcome is it still limited by the limiting reactant? Yes, the answer is yes. Okay, so that means your calculation must be based on HCOOH. Okay, calculate in grams as the form. Okay, try this and then type your answer into the chat once you are done. Maximum yield in terms of ester form. Now, ester is over here. Ester is this molecule over here. Now, I have one propanol, one metanoic acid. Remember, limiting is what? Metanoic acid is limiting, right? Now, metanoic acid limiting means what? 0.08695 moles. That means based on mole ratio, this is 1:1. That means for the ester, there will also be 0.08695 form. Okay. Now, whenever you are calculating MR of an organic substance, it is good to classify in terms of carbon, hydrogen, oxygen. How many carbon, how many hydrogen, how many oxygen? In this case, how many carbon atoms do we have? 1, 2, 3, and 4. I have 4 carbon atoms. Hydrogen, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 hydrogen atoms. Oxygen, how many do I have? I have 2 oxygen atoms. So carbon multiplied by 12, hydrogen multiplied by 1, multiplied by 16. So you go and get your answer. You add everything up. The MR should be 88. And so based on the MR that we have, we are going to use the number of moles to multiply this. Okay. I'll zoom out a little bit for you to see. Okay, answer should be 7.65. Yeah, 7.65. Anybody have different answer? If you understand this, can you give me a thumbs up so I know that we can go on already? Or those of us who cannot understand, can you type inside the chat your question? Everybody okay? Yeah, okay, Rachel, I see your thumbs up. Eva, I see your thumbs up also. Very good. Anybody else have any question? Melissa, okay? Melissa, how come you get 7.22? And Grace also. Everyone, make sure you know how to do part C first. Calculation error for the MR. Okay, can. Okay, so for MR, my tips to you is this. When you're calculating organic molecule, because the organic molecule is very big, so you classify in terms of the elements. If this compound have both oxygen, carbon, hydrogen, write all three down. If it has chlorine, then you write Cl. How many? Calculate individual MR, add them together so that you reduce the chance of having error. Okay? Because it's very big. The molecule is very big. It's very difficult for you to see sometimes. Can Yes, Izati. Use limiting reactant, the mole ratio. Because you see, this one is 0.08695, Izati. So because here, one of these give you one of these. Can you see that? One of the metanoic acid give you one of the ester. One more of metanoic acid give you one more of propanmetanoic. Hence, because I have 0.08695 moles of metanoic acid, I will definitely also get 0.08695 moles of this. So based on the number of moles, because I say mole is a way to translate everything, from here to here, it is the common one. Okay, mass is different. Mass because individual element have individual different masses. So if this is 0.08695 multiplied by its MR, I can get the mass. Okay, remember mole times molar mass. Give you MR. Sorry, give you mass. Can, right? Can I exactly? Okay. Yeah, okay, good. Okay, with that, let's go on to bonding. Okay, so we're done with mole concept already. We do some revision on the different type of questions that we will see in mole concept. Now, in the next 5 minutes or so, or 10 minutes or so, I will give you a recap on chemical bonding. And this part is important, so please pay attention. Okay, now, chemical bonding, Chemical bonding, there are three types of bonding. Please remember what are the three types. One is known as covalent. Number two is known as ionic. And the third type is known as metallic. Now, covalent bonding, why is it called covalent? Co stands for sharing. Valence stands for valence electron. So can you see that when two atoms come together to do covalent bonding, they are sharing their valence electron. This is why it's called covalent bonding. So covalent bonding most of the time happen between atoms of non-metals, okay, atoms of non-metals, okay, they like to share electron. For ionic bonding, metal atom will lose the electron and the non-metal atom is going to gain the electron, okay? Now, whenever we are talking about metal atom losing electron, it forms this thing known as the positive ion. Does anybody know what is the name of positive ion? Type inside the chat. Anybody knows? Cation, very good. Okay, cation. And similarly, when non-metal gain electron, they form what? They form anion. Good. Okay, they form anion, cation. Reason for this is simple. When you explain ionic bonding, you might need to use these terms. So please know these terms. Now, under metallic bonding, sorry, please ignore this header. The header is wrong. Okay, under metallic bonding, metallic bonding exists within metal structures, okay, within metal structures. So I've given you an image of or images of those structures. We are going to go through each of these structures separately, and then after that, we will compare between the structures. Okay, come, let's look at the first structure. Now, under covalent bonding, there are two main structures that we learn. One is known as the simple molecular structure, and the other one is known as the giant molecular structure. Now, some of the school call it the simple covalent structure or giant covalent structure. Both of it is the same thing, okay? So you can use whichever term that you are more comfortable with. Now, you have noticed that I've also abbreviated simple molecular structure to SMS, giant molecular structure to GMS, okay? Giant ionic lattice to GIL, and giant metallic lattice to GML. Okay, this is to help you remember, okay? Now, which molecules undergo SMS? Okay, water, chlorine, HCl, P4O10. These are examples of simple molecules. That means that they exist as discrete molecules that are floating about. Okay, they do not form a large molecule. Okay, Now, my question is this. When I look at a simple molecular structure, you need to understand which is the type of structure and bonding between them, between the molecule, between the atoms, etc. Now, okay, now we look at simple molecular structure again. Now, in terms of simple molecular structure, if let's say I have two molecules of water, I have another water molecule over here. Now, the structure and bonding is like that. The structure is it has simple discrete molecule. Means what? It means it has like that. This is one molecule of water. This is another molecule of water. You need to understand that they are separate molecules that come together. Okay, they do not bond together. Now, the bonding is as such. It is because of the fact that these two molecules, they exist close together. They will have this form of attraction, and this form of attraction is known as a weak intermolecular force. This one you need to understand. What is the type of bonding that we are looking at for each of these structures? Now, weak intermolecular force means what? Because these particles are not charged, that means that they don't have positive, they don't have negative charge. They are just going to come together, interact with each other in terms of their intermolecular force, and that's it. There is no other ionic bond or strong bonds. Okay, it's a weak bond because they are just in close proximity. Now, inter means what? Between molecules. Molecule of water 1, molecule of water 2, they interact with each other by a weak intermolecular force. Now, this has implication later when you are explaining in terms of melting and boiling point as well as physical properties. Why is it that simple molecular structure have low melting boiling points? It is precisely because little energy is required to overcome the weak intermolecular force between the molecule. Okay? So we try to do an explanation. Why is it low? It's because number one, question will always ask this. Explain the boiling point or melting point of a simple molecular structure. Okay, so your key will be this. Little energy is required to overcome the weak intermolecular forces of attraction between the molecules. This is the keyword that you will use. It is weak intermolecular force between the molecules. So there is no mention of atoms, there is no mention of ions, you are just talking about molecules. And hence, because little energy is required, it has low melting boiling point. Okay? Can okay, with that, solubility in water, simple molecules are usually insoluble. It is usually insoluble in water, but it's usually soluble in organic solvent. Reason do you need to know? Answer is no. No need to know. Okay. Simple molecule because they do not contain charged particle. Charged particle means what? Ions, positive and negative. Electrons. Okay. These are charged particles. Because they have no charged particle, they are non-conductor in all physical states. Okay. Next, we look at giant molecular structure. Now, giant molecular structure, basically, it is a very big group of atoms, that are joined together by covalent bond. So we zoom in, can you see each of these lines represent a dot and cross? Same like your organic chemistry, carbon to carbon bond represent there is a dot and cross. This represent a strong covalent bond. This is important for you to know. Between atoms, there exists a strong covalent bond. Okay, with that understanding, this is known as giant molecular structure. Sometimes we call it macromolecular structure as well. Same thing. Okay, same thing. Macromolecular structure and giant molecular structure, same thing. Okay, so macromolecules contain the structure. Now, example of this, graphite, diamond, and SiO2, silicon dioxide is sand. Okay, commonly known, you need to know these three. Now, graphite have this unique structure. This is known as the hexagonal structure, okay, whereby there's layers of hexagonal rings, okay, and between each layer, there is a weak intermolecular force, okay. But among the layer or within the layer, this is a strong covalent bond. Okay, so can you see the dotted ones? Okay, the dotted ones are the weak intermolecular force, whilst the red color ones, they are the strong covalent bond, which means they are a sharing of electrons. Okay, so the structure is as such, there is a strong covalent bond connecting each atom to the adjacent atom, which means this atom is connected by a strong covalent bond to the next atom, so on and so forth. Can? Okay. High melting and boiling point explanation, you need to know as well. Large amount of energy. Okay, is required to break the strong covalent bond. Okay, between atoms. Hence, there is a high melting boiling point. Okay, one thing I forgot to emphasize over here is, can you see if I'm converting H2O liquid to H2O gas, water to water vapor, and you see that there is no change in terms of the bonding. You do not break any hydrogen to oxygen bond. You don't break any OH bond. Okay, so you are only purely overcoming the intermolecular force of attraction. Okay, while for the giant molecular structure, because everything is connected based on strong covalent bond, large amount of energy is required to break the strong covalent bond. Okay, solubility wise, it is insoluble in water, okay, insoluble in organic solvent, and non-conductor of electricity. Okay, if you need to write down something, please write down. Now, you will notice at the bottom, I write there, electrical conductivity, except for graphite. Graphite is a conductor. Why is graphite a conductor? Do anybody know why is graphite a conductor? Can you type inside the chat? There is a free carbon atom that is not bonded. Okay, Melissa said there's a free carbon atom that is not bonded. Anybody have a different answer as to why why does graphite conduct electricity? Okay. Says one free electron acting as charge carrier. Okay. Anybody have different? Okay. One free unbonded electron carries charges. Okay, good. Okay, now, so the answer for graphite, this one you need to know, is in the syllabus. Graphite, because carbon only contains how many bonds? Can you see? This is graphite structure. This is one carbon atom. One carbon atom contains one carbon bond, two bond, three bonds. Now remember, carbon can form how many bonds? Can form four bonds, right? Organic chemistry, we know that carbon CH4, it forms four bonds, right? So that means that carbon, we understand that carbon have four valence electron. When there is only three bonds, that means that only three electrons are bonding. There are three electrons taking part in bonding. Okay, so there is one electron. There is one electron per carbon atom okay, that is not utilized in bonding. Okay, because they do not utilize it in bonding, they are free to act as charge carrier. Hence, they can conduct electricity. Okay, so this is for graphite. Can okay. With that understanding, okay, let's go on to giant ionic lattice structure. Under ionic bonding, giant ionic lattice structure looks like this. Do you need to know how to draw this? No, you don't need to know how to draw this. Okay. Now, giant ionic lattice structure, NaCl MgSO for basically every ionic compound. Okay, basically every ionic compound contains the giant ionic lattice structure. Now, our giant ionic lattice structure contains electrostatic force of attraction between anion and cation, which means, can you see there is a positive ion, there is a negative ion. The force of attraction between unlike charges, this is known as the ionic bond. Okay, and an ionic bond is defined as the strong electrostatic force of attraction between an ion and cation. So whenever the question asks you to explain giant ionic lattice or an ionically bonded structure, you will explain it based on this. You will tell them that it is because there is a strong electrostatic force of attraction, for example, sodium chloride, between the Na plus cation as well as the Cl minus anion. Okay. Now, high melting and boiling points is because of what? Answer is as such, large amount of energy is required to overcome strong electrostatic force of attraction. Okay, in your answer, you must tell them what is the positively charged ion and what is the negatively charged ion. Because of this, there is a very high melting and boiling point. In your answer for exam, you must always have this one over here. Oops. Okay, you must tell them which are the positive and negative that are bonding. Okay, with that understanding, can we try? Okay, maybe we don't try first. Maybe we go to the definition first of properties first. It is soluble to form aqueous ions in water. Okay, because there is a presence of plus and minus charge, they can form aqueous ions in water. Solubility in organic solvent is insoluble in organic solvent. And is non-conductor in solid state. However, it is aqueous solution, it can conduct electricity. Why? Because in an aqueous solution, can you see that the ions are no longer held in a fixed structure? This is a fixed lattice. In an aqueous solution, they are no longer held in this structure. The ions are free to move about in the solution. So for example, if let's say I have a beaker over here, this is NaCl, okay, aqueous, then they will be able to conduct electricity. Okay, any question? If not, we go to the last one. Okay, but metallic bonding. Now, metallic bonding is within metal structures. Okay, all these negative charge that you see over here, these are all electrons. These are all electrons. Basically, there is a giant lattice of positively charged metal ions as well as a sea of delocalized electron. Now, when you see this, it is important for you to understand where does the metallic bond lie. The metallic bond lies between the positive cation as well as the sea of delocalized electron. This is the metallic bond. So similarly, once again, if the exam asks you to answer, what does a metallic lattice structure means? You cannot tell them metallic bond. You must define for them that it is a strong electrostatic force of attraction between the metal cation as well as the C of the localized electron. Okay, high melting and boiling point, same goes. Reason is simple. It is same as the one on the left-hand side, just that it is between, okay, the positive ions as well as the C of the localized valence electrons. Basically, for every metal atom, there is a valence electron, right? So Na, for example, okay, has one valence electron. And this valence electron, they will be used to form the metallic bonding. Yeah, can. So metals are insoluble in water, okay? However, they can conduct electricity in both solid and molten state. This is reasoning is because the electrons are free to move throughout the metallic lattice structure. I say again, the electrons, they are free to move in the giant metallic lattice structure. Can? Any question? If not, can you give me a thumbs up so I know that you are on the same page as me? Okay, thank you, Dion. Thank you, Rachel. Adawiyah, thank you. Shifa, Melissa. Okay, good. Everybody is okay, yeah. Okay, now let's go to the next page. Okay, let's try this. Practice question 1 for chemical bonding. Comparison across structures. Now, this is also a prelim paper question from this year prelim paper. Okay. They ask you about melting points of elements in period 3 of the periodic table. Okay, they ask you to describe general trend, okay, and describe in terms of bonding and structure why they have different melting points. Okay, can we take some time? Can you look at the graph? Okay, look at the graph and try part A. Describe the general trend. Okay, does anybody have any answer? Okay, we look at the graph together. Now, across period 3, can you see that there is an increase? This is the general trend. After that, can you see that there's a decrease? Okay, so the trend is as such, you go up, then go down. Okay, so how do you put that in words? They ask you to describe the general trend of melting points in the elements of period 3. First, you tell me from sodium to silicon. There is a general increase in melting point. Okay. Then after that, from silicon to chlorine, okay, there is a decrease. There is a general decrease in melting point. This is what is known as a general trend. Okay, general trend means how does the graph generally look like? Does it look like go up then come down, or is it just an increasing graph, or is it just a decreasing graph? Okay, this is a general trend. Hannah? Okay, with that, part B, in terms of bonding and structure, why does magnesium and phosphorus have different melting points? Okay, try to write out an answer for this part B. Go through. Okay, part B, explain in terms of bonding and structure. Okay, first off, can anybody tell me for this question, okay, when we're talking about structure and bonding, we are looking at magnesium and phosphorus, right? Can you first tell me, anybody inside the chat, magnesium is what kind of structure? we have the four structure just now, right? We have the four acronym. Simple molecular structure, SMS. Giant molecular structure, GMS. Okay. Ionic, GIL. And metallic, GML. What structure is magnesium? Okay, JH says metallic. Okay. Giant metallic lattice, Rachel say. Okay, good. So, yes, fantastic, Dion. Okay, so magnesium has a giant metallic lattice structure. Now, same goes for phosphorus. What does phosphorus have? What kind of structure does it have? Simple molecular structure, giant molecular structure. Rachel says simple molecular structure. Anybody else have any answer for phosphorus? Anybody say giant molecular structure? Metallic structure. Okay, JH also said simple. Okay, so phosphorus have a simple molecular structure. Okay, thank you. Now, in this question, they are asking you to explain in terms of bonding and structure why they have different melting points. So, when they say different melting points, you have to tell me, based on the graph that you see, which one is higher, which one is lower. We are comparing magnesium and phosphorus, right? Okay, based on explanation, it must come to the point that there is one that definitely must be higher than the other one. And in this case, giant metallic lattice structure has a higher melting point than simple molecular structure. Okay, first, how do you go about explaining? First, you tell me magnesium has a giant metallic structure, metallic lattice. Okay, this is the structure. Now, what about the bonding? Bonding, you can explain in terms of melting point. Now, if you are my student, you know that whenever I say melting point, you must always talk about the E word. E word stands for energy. Now, so when we explain about bonding, I can just go straight to it and talk about energy. So large amount of energy is required. Okay, this will be the answer that you give. Large amount of energy required to overcome. Now, here comes the bonding. The bonding is strong electrostatic force of attraction between the magnesium ion and sea of delocalized electron. Okay. Hence, this is what? High or low melting point. This is a high melting point, right? So this is how you answer. This is the simplest way to answer. It's a very step-by-step process. First, you tell me what kind of structure does it have, followed by bringing the concept of energy, talking about the bonding. Okay. Now, some students, they like to structure the answer in the way that you talk about the bonding first, then you talk about structure, then after you talk about energy. But that way, it's repeated, a lot of repetition, because you tell me that the bonding is as such. The bonding is there is a strong metallic bonds between atoms of magnesium because there is a magnesium ion and a sea of delocalized electron. Then you talk about structure. It is a giant metallic lattice structure whereby there is a structure of positive lattice of magnesium ion as well as a sea of delocalized electron. Then after that, you explain in terms of melting point, or because there is a high melting point because a lot of energy is required to overcome the strong electrostatic force of attraction. You repeat a lot of time. Can you get it? So if that's the case, we simplify it. First, you tell me about the structure. Following which, you tell me about the energy requirement. Then you tell me about the melting point. Can already. Okay. So similarly for phosphorus, you will use the parallel structure. Phosphorus has a simple molecular structure. Okay. Now, simple molecular structure. Little energy required to overcome in this case, because it's simple molecular structure, which means phosphorus, 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 there is weak intermolecular force. Okay, the weak intermolecular forces of attraction okay, between phosphorus molecules. Hence, low melting point. Can you see that? Easy to explain? Can I? So always tell me what is the bonding and structures related to energy. Okay, so there is a reason why I give you this summary table and I tell you to write down how do we explain melting point, because melting point is the most commonly tested concept, and this is the things that you can prepare for before going for your O level. Imagine now you go for your O level, you already have the marks in the paper before you even start doing the paper. This is how you prepare yourself. Okay, can part B okay okay, with that understanding, shall we go on to the next part? Okay, so this part we are talking about bonding and structure, why magnesium has a giant metallic lattice, and why does phosphorus have a simple molecular structure. Now let's go to part C. Shall we try to draw dichlorine monoxide? Okay, everybody try to draw dichlorine monoxide. Yeah, dichlorine monoxide, how does it look like? You must, whenever you draw dot and cross diagram, you always identify which is the atom that requires most electrons to obtain stable structure. That means what? That means the atom that has the least number, they can form the most number of bonds. Okay, so in this case, it's oxygen. Oxygen can form 2 bonds, right? Because there's 6 valence electron. Okay, chlorine have 7 valence. Okay, so oxygen will be the central atom. Okay, chlorine will be the ones at the side, Cl, Cl. Now, dot and cross diagram for dichlorine monoxide, very simple. We have 6 electron for oxygen, 7 electron for chlorine. Okay, so this will be your structure for dichlorine monoxide. Okay, this is also a reminder to everybody, do not use triangle in a dot and cross diagram. Okay, now if let's say it happens that there are 3 different elements that you need to draw, okay, and you repeat the dot and cross, what is the key? The key is you need to alternate. That means that if let's say this is bonded to something else, then you alternate between the dot and the cross. Okay, so it's, for example, chlorine is a dot, then the next atom should be a cross. Okay, there's a question in the chat. What is the process of drawing Lewis structure of big atoms? You only need to know how to draw dot and cross. No need to know how to draw Lewis structure. Okay. For O level, no need to know how to draw Lewis structure. But to answer your question, if let's say I have big atoms, okay, first step you will always identify the atom that requires most number of electron. This one will be the central atom. Identify which is the central atom. So for example, like NH4, okay, if you draw NH4 plus the cation ion, okay, you need to know that NH4 looks something like this, okay. If you are drawing an atom, if you are drawing let's see, H2O, okay, H2O very simple as well. H2O, oxygen will be in the center, hydrogen will be at the corners. Okay, so you always follow that requires the most electron to obtain the stable structure. Then after that, the second step is decide how the bonds, okay, are connected. And then you draw the structure. And okay. Second part, is anybody okay with second part already? If you're done with second part, can you type a okay inside the chat? If you're done with part 2, can you type okay in the chat? Okay, Melissa is done. Okay. Okay, Rachel is done. Okay, Adawiya is done also. Okay, JH is done. Okay, good. Let's go through this. Shiva is done also. Okay, suggest a reason for the difference in the boiling points of the two compounds. Now, first off, we are comparing what? Dichlorine monoxide and phosphorus oxide, right? Now, P4O10, you need to know that this is a simple molecular structure. Just now we go through already. Dichlorine monoxide, because the boiling point is so low, definitely it is a simple molecular structure as well. Okay. So why is there then a difference between the boiling points? Why is it then both of them are simple molecular structure, but one have 2.0 as the boiling point, the other one is 360.0. Okay. Answer is as such. Now, intermolecular force, maybe let's go back to our table. This one maybe you write down. Additional info for you. The intermolecular force is proportional to the size of the molecule. That means what? That means if it's a bigger molecule, it can exert a larger interaction between the molecules, right? So if I am heavier, I can have some form of larger attraction between another heavy molecule, okay? The size of molecule, if it's larger, the intermolecular force between the molecules, they are stronger. Although I say it's a stronger intermolecular force, does it mean that it is a strong force? No, it is not a strong force. It is still a weak force, just that it is a stronger, it's less weak. Okay, less weak. Okay, so we look at these two. Clearly, we compare Cl2O and P4O10, which is the larger molecule. P4O10 is definitely going to be the larger molecule. If you simply calculate the MR, you can already tell, right? P4O10 MR will be much, much, much greater than Cl2O. Okay? Now, so the answer is as such. You can tell me first off that P4O10 and Cl2O have simple molecular structure, as P4O10 is a larger molecule. Intermolecular forces of attraction between molecules of C4O10 is definitely going to be higher. Hence, more energy required to overcome the intermolecular force of attraction in P4O10 than Cl2O. Okay, and therefore P4O10 has a higher boiling point than dichlorine monoxide. Now let's go on to question number 2 for chemical bonding, the last question for today. Okay, we are going to wrap up very, very soon. Now, they tell us that there's the compound known as boron nitride. It is a widely used compound in makeup. It is shimmery, slides smoothly onto skin, and chemically unreactive. They tell us that the structure is very, very similar to that of graphite. Can you see it is a hexagonal rings, okay, with layers of hexagonal rings. Okay, Now, in A, they are asking you the property of a hexagonal ring arrangement. They are asking you to bring your content that you know about graphite into applying it for this case. This case is where we see the same structure, but for different elements. So does the concept change? No, it doesn't. It still stays the same. So when we are asked this, we just tell them that because there are layers of hexagonal ring, okay, are held together. This one over here, this is a weak intermolecular force because, oops, when you push a force over here, then this whole part will move forward. Can you see that? Because these are all weak forces, then it will just slide over one another. The two layers will slide over one another. Okay, held together by weak intermolecular forces of attraction. Okay, a small amount of force, okay, would result in a layer sliding over one another. Okay, because you tell them that there is a layer. Okay, there's a force applied. Okay, then there'll be a layer of atoms that slide over one another. Okay, Eldon, I saw your question. Okay, I'll come back to you in a bit. Can I? Okay, so this is for A. Now, meanwhile, can you try to do B? Okay, they tell you that both nitride and graphite have giant molecular structure. Okay, try to do B. Okay, then Eldon, I will come to your question. Okay, shouldn't it be a strong intermolecular force of attraction rather than weak that requires more energy? Okay, so I mentioned just now when we are looking at this part over here, every time when we are looking at simple molecular structure, we are always looking at weak intermolecular force. Now, the term weak intermolecular force comes in one package, okay? It comes in one package. There is no strong intermolecular force and weak intermolecular force. It's just weak intermolecular force, okay? Now, weak intermolecular force means what? The term weak over here, it represents the fact that the force is between uncharged molecules. You need to understand this first. So when we write our explanation, we cannot say strong intermolecular force. We can only say it is a stronger weak intermolecular force. Can you get what I'm saying? The weak IMF is stronger. Okay, the weak IMF of molecule A is stronger than the weak IMF of molecule B. Yeah, so similarly, if we come to here, so sorry, should have a word weak here. Okay, so as P4O10 is a larger molecule, the weak IMF between molecules of P4O10 is larger. So that means the intermolecular force is slightly stronger. Okay, more energy is hence required to overcome the weak intermolecular forces in P4O10. Because the weak IMF in P4O10, can you get this is stronger? This is stronger than Cl2O. Can you see that? Because this is like that, right? Hence, P4O10 is going to have a higher boiling point than Cl2O. Can Eldon? Okay, Okay, good. Okay, we are down to the last question, okay, on boron nitride. Okay, once you're done with part B, can you type okay in the chat to everybody? Once you're done with part B of the question, can you type okay into the chat? Okay, JH done already, very good. Okay, wait for the rest. A few more of you to be done with this part. Okay, Dion, okay, Okay, Melissa, okay. Okay, let's go through. Now, boron nitride and graphite both have giant molecular structure. Means what? Means they all contain this form of structure where the atoms are all covalently bonded. Now, in terms of bonding, why does graphite conduct electricity, but boron nitride does not conduct electricity? We understood earlier that graphite, because of its one delocalized electron, right? We go back to our summary. Can you see over here? Each of the carbon atoms is only going to form 3 covalent bonds. Because they form 3 covalent bonds, there is still one electron here that is left unbonded. Hence, that is the reason why graphite can conduct electricity. One electron per carbon atom that is not utilized in bonding, they can act as a charge carrier. Now, however, for boron nitride, does it? It doesn't. Boron nitride don't have, right? Boron nitride cannot. So sorry, my screen is a bit laggy. Give me a moment. Okay, let me reshare my screen. Okay, so for boron nitride, as mentioned, it cannot form, or rather, there is no mobile charge carrier available for bonding, right? Or for conducting of electricity, right? So hence, with that understanding, okay, how will the explanation go? Okay, now boron is in group 1. If you open your periodic table, you realize that boron is in group 13. Means they have 3 valence electron. All right. Now, let's say these atoms is boron. They form 3 bonds, right? 3 electrons to form 3 covalent bonds. Now, when they form these 3 covalent bonds, means what? These 3 covalent bonds, when they form, hence all of the atoms in boron are all participating in bonding. They are no longer available to conduct electricity. All are used up in terms of bonding. Okay? Can. Now, with that understanding, okay, can we try this? So we tell them that first off, okay, in boron nitride, all valence electrons are used up in bonding. To make your answer more specific, no mobile or free charge carrier available to conduct electricity. For graphite, it's slightly different based on what we say just now. One valence electron per carbon atom, okay, what happened to the one valence electron is not utilized in covalent bonding. Okay, with that understanding, because they are not utilized in covalent bonding, the electron can hence a mobile charge carrier to conduct electricity in graphite. So you explained to me in boron nitride that there is no mobile charge carrier. Whilst for graphite, because there is one valence electron per carbon atoms that is not utilized in covalent bonding, they can undergo, they can mobilize to conduct electricity. This question apply for pure chem only. Okay, combined chem not necessary to know giant molecular structure. Okay, this question, comparison between 2 of the same structure, where both of it are giant molecular structure. I need to compare the difference between the same structure, okay, of 2 different kind of molecular formulas. All right. Okay, so this is the recaps that we have done today. Okay, basically we go through chemical bonding, okay, covalent bonding, ionic bonding, and metallic bonding, and what are the type of structures that each of these bonding types actually have. All right. Okay, before we end off today's session, I think we are all okay. If you have any other question for today's session, you can stay back and ask me. If not, then okay, it is a good 2 hours that I spent with you doing more concept questions and chemical bonding questions.